Hi, today you're going to be learning about the ionic radius from my co-host Ani Gonzalez, Jesus, Jessica, and Kitty Cat Katarina. Let's begin. The introduction. A cation is a positive ion. An anion is a negative ion. A group of trends are the metals on the left and the periodic table, usually from cations on and non-metals on the right, usually form anions, which are negative. And the periodic trend. Don't worry, this is not all of it. We'll go in more depth.
Cations. To start off, an ion is an atom or molecule in which the total number of electrons is not equal to the total number of protons, giving that its net positive or negative electrical charge. With that said, a cation is an ion which has a net positive charge, is attracted to the anode, which is just a positive electrode, and electrolysis. The positive charge is acquired as a number of protons exceeds the number of electrons in one atom.
Alright, pineapples. So, we're going to break it down and make it a little bit more easier for you guys to understand. As you can see in the diagram, a positively charged ion, when it wants to gain an electron, it goes to the negative electrode, as in the picture, and then it gains an electron. A negatively charged ion, to lose an electron, it goes to the positive side to lose its electron. And when a cation loses one or more electrons on the atomic radius, it decreases. As you can see on the periodic table, or your periodic table, when an atomic radius decreases, it goes to the right, past the metals to the non-metals, as my partner Jesus explained. And also, the electrons are left or drawn towards the nucleus because it's unbalanced. As you can see in this picture, one cation says to the other, "Chit, I lost an electron. Are you sure?" "I'm positive." This cation became positive because it's lost an electron and has become unbalanced.
Anion. The formation of an ion by the addition of one or more electrons always leads to increase in atomic radius.
Alright, in this diagram we have two different types of elements, lithium and chlorine. The lithium cation is smaller than the lithium atom because lithium is positive and it hasn't gained or lost an electron. The chlorine ion is significantly larger than the chlorine atom because it's a negative and it's lost an electron.
Because the total positive charge of the nucleus remains unchanged when an electron is added to an atom or an ion.
In this picture, you have two types of atoms, sodium, which is positive, and chloride, which is negative. Sodium loses an electron and chloride gains an electron, but chlorine changes and sodium does not because it's closer to the nucleus.
So the electrons are not drawn to the nucleus as strongly as they were before when the extra electron was added. The electron could also spread out because of the increased number of electrons.
Group trends, the outer electrons in both cations and ions are in higher energy levels as you read down a group. Just as there is a gradual increase of atomic radii down a group, there is also a gradual increase in ionic radii. Cations are smaller and ions, are larger than the atomic atoms from which they are formed.
Within each group, radius tends to increase from top to bottom.
So as you can see in this picture of the periodic table, and in the periodic table, the ion, as my partner explained, as you go down or up, and the atomic radius becomes smaller or larger because it is farther or closer away to the nucleus. And also, as you go down, the number increases because it's from you have a larger orbital than is far away from the nucleus within each period of the atomic radius.